When we found delta y by delta x here, what did we get? For any range of values of x, we are getting delta y by delta x is equal to, it's a constant. In y is equal to x square, what was delta y by delta x that we are getting? What is it? Delta y by delta x is equal to 2 into 2x plus delta x, is it? Is that correct? Check. And for x square plus x, what was delta y by delta x? We were getting
2x plus 1 plus delta
2x plus 1 plus delta.
x.
Okay. Let's talk about this third one later. 3 should be enough for us to understand what we are doing here. All right. Here, look at these three functions here. Let's take the second one. Let's take the second one. Y is equal to 2x square. In the second one, delta y by delta x is equal to 2 times 2x plus delta x. This is what we have. If x changes from say 2 to 2.1, what will you get delta y by delta x? What's the rate of changing y with respect to x? When x changes from 2 to 2.1. So x is 2, delta x is how much? 0.1. X changes from 2 to 2 plus 0.1. 2.1 is what? 2 plus 0.1. So x is equal to 2 and delta x is equal to 0.1. So what would you get? Tell me. X is equal to 2. Delta x is equal to 0.1. What are you getting? 4 plus 0.1. How much? 4.1 plus 2. Sorry, into 2. What do you get? 8. So you get delta y by delta x is equal to 8.2 or 8 plus 0. Let me write it like this for the time being. So I am making the interval smaller and smaller. If x changes from 2 to 2.001, now let's make the interval smaller. Okay, if x changes from 2 to 2.001, what will you get delta y by delta x equal to? Are you following this? Are you following this? Now, if x changes from 2 to 2.001, you get delta y by delta x is equal to, now you understand the pattern, right? What are you getting? 8 plus 0.00. Understand this? Here, I'll give you one more, 3 more examples. X changes from 1.9 to 2. When x changes from 1.9 to 2, x is equal to how much? 1.9. Delta x is equal to how much? 0.1. X is equal to how much? 1.9. Delta x is equal to 0.1. Now tell me what is delta y by delta x in this case. Tell me what is delta y by delta x in this case. Huh? X is equal to how much? 1.9. 1.9 into 2? 3.8. 3.8 plus delta x. Delta x is how much? 0.1. 3.9. 3.9 into 2? 7.8. 2 into, you are very poor in calculations. 2 into 3.8 plus 0.1. 2 into 3.9. So what do you get? 7.8. Okay. You understand this? Voice was check. So 7.8 is how much? 8 minus 0. Now come closer to 2. Come closer to 2. 1.992. What do you get? You will get delta y by delta x. Here you got 7.8. Here you will get 7.98. So you will get how much? 8 minus 0.02. Come further close to 2. You will get how much? Delta y by delta x is equal to, you will get how much? 7.998. So by looking at the pattern, you can understand that on the number line, if this is x is equal to 2, as the interval around 2 becomes smaller and smaller, interval, here the interval is how much? 0.1. Here it is 0.01. Here it is 0.001. As the interval becomes, as you approach 2 from the right side on the number line, from greater numbers. Okay, you approach 2 from 2.1, 2.01, 2.001. Are you following what I'm saying? As you approach 2 from, so this is, let's say, this point is 2.1. This would be 2.01. This would be 2.001. So as you make intervals smaller and smaller, delta y by delta x is coming closer and closer to which number? Delta y by delta x is coming closer to which number? 8. You understand this? So as you approach 2, as x approaches 2, okay, x is approaching 2. Interval becoming smaller and smaller means what? Delta x is becoming smaller and smaller means this is approaching 2. Okay. So as around x is equal to 2, as delta x becomes smaller and smaller, delta y by delta x approaches which number? 8. You understand this? Similarly, on the left side of x is equal to 2. When the interval is 0.1, 1.9 to 2, interval is 0.1. Look at delta y by delta x. Make the interval smaller. Come closer to 2 from the left side. What are you getting? Delta y by delta x becomes, becomes closer to 8. Is coming more close to 8. This is even more close to 8. Are you following what I'm saying? So can I say here also delta y by delta x is approaching 8? You understand what I'm saying? Okay. So the conclusion here is that as delta x becomes smaller and smaller, as delta x at x is equal to 2 or around x is equal to 2, at x is equal to 2, delta x, as delta x becomes smaller and smaller, delta y by delta x approaches which number? Approaches 8. Is this understood? Similarly, if it's not 2, look at some other number. Instead of taking x is equal to 2, now take x is equal to 3. Okay, delta x is becoming smaller and smaller. Delta x is very, very small. When delta x is very, very small, if the interval is very, very small, can I neglect this term here? Addition. If this is 1 lakh rupees and this is 1 rupee, you shouldn't neglect it in multiplication. You understand what I'm saying? It's addition. When you add 1 rupee to 1 lakh rupee, can I neglect that 1 rupee or not? Addition or subtraction when compared to 1 lakh rupees? Okay, so here delta x, when delta x becomes small, when delta x, I'm going to generalize this, when delta x becomes very small, delta y by delta x is equal to, what do you have? 2 into 2x plus delta x. This delta x becomes negligible. Okay, adding 1 to 1 lakh, okay, doesn't make us any more richer. Okay, so this delta x becomes negligible. In other words, as delta x becomes smaller, delta y by delta x approaches, can I say 4x? Can I say, if I neglect delta x, what do I get here? 4x. So delta y by delta x approaches which number? 4x. You understand this? If you construct a small interval around x is equal to 2, you will get delta y by delta x almost equal to how much? 8. Okay, around x is equal to 2, delta y by delta x is approaching which number? 8. Is this understood? Around x is equal to 3, if you construct a small interval, delta y by delta x is close to which number? 12. 4 into 3. Around x is equal to 1.1, if you construct a small interval, around x is equal to 1.1, if you construct a very small interval, you would find that delta y by delta x is close to what? 4.4. 4 into 1.1. You understand what I'm saying? Okay. So here the conclusion is that as delta x becomes smaller, it means as delta x approaches 0, not equal to 0, approaches 0, becomes small. That's all I'm saying. Don't take it equal to 0. Delta x is not 0. Okay, delta x becomes very small. Okay, approaches 0, or we say tends to 0. As delta x approaches 0, or you can say as delta x tends to 0. What can I say? Delta y by delta x approaches 4x, or tends to 4x, tending towards that number. That's what we are saying. Is this understood? Delta y by delta x tends to 0. So mathematically, we write it as delta x tends to 0. This arrow mark indicates that delta x is not equal to 0, but delta x is becoming small. You understand what I'm saying? Okay, delta y by delta x is approaching which number? 2x. Which function are we talking about? In the function y is equal to 2x square. This is the example that we have been discussing from yesterday. In the function y is equal to 2x square, when we found delta y by delta x, we got this expression. Okay. In this expression, delta x becomes negligibly small for small values of delta x. Okay, so as delta x tends to 0, this becomes negligible. So delta y by delta x is approaching 2x. Okay, we write this mathematically as that's how we write it. What does this mean? It means in the limit delta x tends to 0, delta y by delta x tends to 2x. Okay, so the same thing we say it in English. In the English language, I am writing here. This is the language of mathematics. In the language of mathematics, what does this mean? What does it mean in the language of mathematics? In the limit delta x tends to 0, this is a symbol of limit. In the limit delta x tends to 0, delta x tends to 0, delta y by delta x approaches or tends to 2x. Okay. So this equation is nothing but this sentence. This equation just says that as delta x tends to 0 in this function, delta y by delta x approaches 2x. Do you understand this? We have seen when x is equal to 2, delta y by delta x approaches. When x is equal to 2, this is 2 into 2x. You are not correcting it. 4x. Until here I wrote 4x. This is 4x. This is 4x. 4x. Right. So when x is equal to 2, what do you get? Delta y by delta x equal to 4 into 2, 8. What does it mean? Around x is equal to 2, if you construct a small interval, in that small interval, you will find that delta y by delta x is very close to which number? 8. Around x is equal to 3, if you construct a small interval, delta y by delta x close to which number will you get? 12. You understand what I'm saying? Around x is equal to 4, if you construct a small interval, you'll get delta y by delta x close to which number? 16. Okay, so it means in a small interval around x is equal to 3, as delta x approaches 0, delta y by delta x approaches 12. That's what it means. You understand the meaning of this? This is very, very fundamental to what we are going to discuss next. Note down this, please. I'll give you one more example, don't worry. All right. Look at one more example. The third example that we discussed here. Where for this function, y is equal to x square plus x. When we calculated delta y by delta x, this is what we got, right? Is this what we got? Huh? Okay. Now, in this function, tell me, as delta x approaches 0, as delta x tends to 0, take this example only. Take this example only. As delta x tends to 0, what would you get? Delta y by delta x equal to, this becomes negligible. Delta y by delta x becomes approximately equal to 2x plus 1. In other words, as delta x approaches 0, delta y by delta x approaches 2x plus 1. Okay. What it means is, take this function. At x is equal to 3. Construct a small interval around x is equal to 3 to 3.001. You will get delta y by delta x approximately equal to 2 into 3 plus 1. How much? 7. If you don't believe me, you can check it yourself. Take x is equal to 3, delta x is equal to 0.01. Take x is equal to 3 and delta x is equal to 0.01. You will get 7.001. Okay. So if you make it even more small, if it becomes even smaller, what happens? It will become very close to 7. So can I say as delta x approaches 0 around x is equal to 3, delta y by delta x approaches to x plus 1. Okay, so at x is equal to 3, at x is equal to 3, what would you get? Delta y by delta x approaches to x plus 1, that is 7. In other words, we write it as limit delta x tends to 0, delta y by delta x in this case is how much? 2x plus 1. What it means is in the limit delta x tends to 0, delta y by delta x approaches 2x plus 1. You understand this? Or else we can also write this special case. Which special case we are getting? At x is equal to 3, how much are we getting? 7. So it means in the limit x tends to 3. X tends to 3 means delta x around x is equal to 3 tends to 0. When I say x tends to 3, when I say x approaches 3, what it means is around x is equal to 3, delta x is becoming smaller. So in the limit x tends to 3, delta y by delta x approaches which number? 7. Do you understand this? Do you understand this? Okay, so this is limit delta x tends to 0, delta y by delta x is also the rate of change in y, the rate of change in y with respect to x, where in a small interval constructed around that value of x, isn't it? What are we doing if x is equal to 3 is given? We are constructing a small interval around x is equal to 3. In that small interval, we are finding delta y, and we are finding delta x, and we are finding this ratio. You understand what we are doing here? And what is this? This is nothing but rate of change in y with respect to x. Where? Rate of change in y with respect to x. Where is this? Where is it equal to rate of change in y with respect to x? In a small interval around x is equal to 3. We also call this instantaneous rate of change in y with respect to x. Rate of change in y with respect to x, you can say this is at a given value of x. We call it instantaneous rate of change in y with respect to x. I'll give you an example. You are going on a bike, let's say. At an instant, when you look at the speedometer, it shows 20 kmph. At a particular instant, when you look at the speedometer, it shows 20 kmph, 20 km per hour. What does that mean? Does it mean you have traveled 20 kilometers until then? What does that mean? Speed of the vehicle is 20 km per hour. What do we mean by speed of the vehicle is 20 km per hour? If you accelerate it, in the next minute it will show 30. What has changed from now to then? What do we mean by speed changing? The ratio of distance covered to time, isn't it? Speed is what? The ratio of distance covered to time. So at an instant, say 10 o'clock, at 10 a.m., you're traveling on a bike at 10 a.m. When you look at the speedometer, it shows 20 kmph. When you look at 10:10, 10 minutes after that, the speedometer shows 30 kmph. What has changed in these 2 minutes? In these 10 minutes, speed has changed. What do we mean by speed here? How does speedometer know your speed? So at 10 a.m., what is speed? Define speed. Distance covered in a unit time, or the rate of distance covered, isn't it? With respect to time. You understand what I'm saying? Speed is distance covered in a unit time, or the rate of distance covered, which is similar to what we are saying here. So what are we doing? The rate of distance covered, we are finding rate of distance covered at one particular instant of time, not in an interval. We are not taking, okay, 10 a.m. to 11 a.m. this fellow traveled 10 kilometers, takes this much time, find out the speed. If you find the speed that way, you will get average speed. You understand what I'm saying? Okay. This fellow traveled from 10 a.m. to 11 a.m. Okay. Traveled for 20 kilometers. Then the speed that you get is average speed. Total distance covered by total time. But the speedometer, what the speedometer shows at a particular instant is not an average speed. It is speed at that particular instant. Okay, we call it instantaneous speed. Okay, how do we find speed at a particular instant? In a given time interval, we know to find speed. In a given time interval, suppose if 1 hour time interval is given, we would see how much distance that fellow has traveled. We will write a distance by time. We will get average speed. That is in a given time interval. Are you following me? But what we are doing here is to find speed at a given instant of time. Okay, speed at a given instant of time. To find speed at a given instant of time, construct a small interval around that given instant of time. Around 10 a.m. Your watch shows 10 a.m. So around 10 a.m. construct a small interval. How much small? There is no rigid fixed boundary to it. Okay, it has to be very small. When I say very small, it doesn't mean it is 0.001. No, we don't have a fixed boundary to it. It has to be close to 0, but not equal to 0. Okay, construct a small time interval around 10 a.m. In that small interval, find the distance. Maybe you'll get 1 millimeter or 1 micrometer or 2 millimeters. You understand what I'm saying? Okay, if you get 1 millimeter or 2 millimeters, whatever the distance that you get. So find out the distance, which is very, very small. You can call it delta S or S. Find out the time interval. Time interval is, you already know, small interval. Do delta S by delta T. Small distance covered by small time interval around which point? Around 10 a.m. Okay. So what is this? This is rate of change in the distance covered in a small time interval around a particular value of time, around a particular instant of time. You understand what I'm saying? Which is nothing but speed at that instant. We also call it instantaneous speed or instantaneous rate of change in the distance covered with respect to time. So when I say instantaneous rate of distance covered or instantaneous rate of change in y with respect to x, we are talking about rate of change in y with respect to x at a given value of x. When I say given value of x, what does it mean? In a small interval around that given value of x. Okay. When you construct a small interval around a given value of x and find delta y by delta x, you would see that this approaches a particular value, like this example. Like this example. You understand this? Okay. We also call this instantaneous rate of change in y with respect to x. You can call this instantaneous rate of change in y with respect to x. Okay, when you construct a small interval around a given value of x, because the interval is small, the change is small, small changes are indicated by not delta but d. Okay, d does not have any independent significance to it. Okay, if you write d, it doesn't mean anything. If you write dx, what it means is change in x. For change, we already have the symbol delta. Why are we writing d? D indicates small change. Dx is small change in x. Dy is small change in y. So here we are talking about small changes only, right? So here limit delta x tends to 0, delta y by delta x is also called, it can also be written as dy by dx. What is dy by dx? Rate of change in y with respect to x, where at a given value of x. What is delta y by delta x? Or y2 minus y1 by x2 minus x1? What is this? Rate of change in y with respect to x, but not at a given value of x. This is in an interval. In the very beginning of this class, what did I say delta y by delta x is? Average rate of change in y with respect to x in the given interval of x. You understand the difference? Okay. How do you find average speed? In a given time interval, you find the distance covered by a body and total distance covered by total time interval will give you average speed. Suppose from here to go high-tech city, you go 10 kilometers. Let's say it takes 30 minutes. You would say average speed is how much? 20 kilometers per hour. But does your speedometer show at every instant 20 kilometers per hour? No. Sometimes it shows 0, sometimes it shows 30, sometimes 40, sometimes 10. So your instantaneous speed is different at different instants. Okay. So the distance covered, the first 1 meter, the time taken for the first 1 meter is not necessarily same as the time taken for the next 1 meter, not necessarily same as the time taken for the next 1 meter. The distance covered in first 1 second is not necessarily same as the next 1 second, not necessarily same as the third 1 second. Okay, so it is varying speed. It means from instant to instant speed changes. So when you want to find speed at a given value of time, you construct a small interval in that given time interval. Okay, at that given time, you construct a small interval, find out the small distance covered by small time interval around that given instant will give you instantaneous speed. Are you following what I'm saying? Okay. So dy by dx is what? Instantaneous rate of change in y with respect to x is instantaneous rate of change in y with respect to x, or this is what? Rate of change. I am writing it again. We wrote it anyway, but I am writing it again. Rate of change in y with respect to x at a given value of x, or mathematically speaking, this is also called derivative of y with respect to x. Mathematics people say this is derivative of y with respect to x. The process of finding derivative of y with respect to x is called differentiation. The process of finding dy by dx is called differentiation. You understand this? I'll give you 1 or 2 examples in physics. Speed example. Speed at a given instant. We also call this instantaneous speed. Speed at a given instant is ds by dt. What is ds? Small distance covered.
What is dt? Small time interval around a given particular value of time. If you want to find speed at 10 a.m., around 10 a.m. construct a small interval. In that small interval, find the distance covered by time. Will give you speed. Because these are small values, this prefix d indicates that this is a small change in s. Don't cancel d and write s by t. No. Don't ever do that. Okay. So d indicates change. It's just a prefix. V is equal to ds by dt, or we write this as limit delta t tends to 0 delta s by delta t. That's how we write it. Similarly, acceleration, instantaneous acceleration, or I'll write instantaneous acceleration. You know what is an acceleration? What is acceleration? Rate of change in velocity with respect to what? If it's not mentioned, it is with respect to time. Rate of change in velocity with respect to time. So instantaneous acceleration, A is equal to, how would I write it? How to write it? A is equal to delta V by delta T, but we are finding instantaneous acceleration. So what should I write in place of delta? D. So what do we write here? A is equal to dV by dt. If you are finding average acceleration in a given time interval, suppose a body traveled from 10 a.m. to 12 a.m., 12 p.m. Okay, its velocity changes from 10 kilometer per hour to let's say 30 kilometer per hour. Okay, then you would find change in velocity 30 minus 10, and time interval is 2 hours. Okay, change in velocity 30 minus 10, time interval is 2 hours. You would say 10 kilometer per hour square is acceleration. But this acceleration is what? Average acceleration. This acceleration is average acceleration. This is not acceleration at an instant. Okay. So when speed increases from 10 to 30, doesn't mean that it continuously increases. Not necessary. Maybe somewhere in the middle, speed have become 0. So what we are finding is average acceleration. What is this? This is instantaneous acceleration. Acceleration at a given instant of time. We can write this as limit delta t tends to 0 delta v by delta t. Are you following this? Note down this, please. I'll give you one problem. Please try this. Y is equal to 2 plus x whole square. Find dy by dx at x is equal to 3. How do we do it? First, we will find delta y by delta x. General expression for delta y by delta x. When x changes by delta x, how do we write this? Y is equal to y plus delta y is equal to, yes, please tell me. 2 plus x plus delta x whole square. Simplify and get delta y by delta x for me. Simplify this, expand it. Okay, expand also this 4 plus x square plus 4x. Is it? Okay, certain terms get cancelled. Get delta y by delta x. What are you getting? When you expand this, call this A, this has B 2 plus x plus delta x whole square plus 2 into x plus delta x, A plus B whole square. Simplify this. What do you get? 2 plus, expand it further. X square plus delta x whole square plus 2x delta x plus 2x plus 2 delta x. Correct? Check this. Huh? This is 2 square, 4. X plus delta x whole square plus 2 into 2ab. Is a plus b. A square plus b square plus 2ab. 4 plus x square. 4 plus x square plus delta x whole square plus 2x delta x plus 4x plus 4 delta x. Look, 4 plus x square plus 4x. 4 plus x square plus 4x is equal to what? Y. Get cancelled. So what do you get? Delta y equal to delta x. I'll take delta x common in these three terms. What do you have? Tell me. Delta x plus 2x plus 4. So delta y by delta x equal to, what are we getting? Delta y by delta x is equal to 2x plus 4 plus delta x. Look here. What is dy by dx? Dy by dx is as delta x approaches 0, delta y by delta x is called dy by dx. As delta x approaches 0, can I say this becomes negligible? So as delta x approaches 0, tell me what is delta y by delta x approaching? 2x plus 4. You understand this? At x is equal to 3. So at x is equal to 3, dy by dx is equal to how much? 2 into 3 plus 4, 10. Right? So instantaneous rate of change in y with respect to x at x is equal to 3 is 10. That's what it means. You understand this? If you don't understand anything, please tell me. Instead of doing this cumbersome procedure every time we are asked to find dy by dx, we have some differentiation formulae. Some beautiful differentiation formula we have. Very simple. This whole process of finding dy by dx is called what? Differentiation. I'll write differentiation formulas. First one, y is equal to x power n. how to find dy by dx. I'll tell you how we get the formula also. Okay. In some cases I'll directly write. In most of the cases, I'll tell you how we get the formula. If y is equal to x power n, tell me what is y plus delta y equal to? If y is equal to x power n, y plus delta y is equal to x plus delta x whole power n. y1 is equal to x1 power n, y2 is equal to x2 power n. Are you following this? Huh? Okay, listen to me. Y plus delta y, I'll write here x in the numerator, x in the denominator in the right term. I'll take x out. What do you have? Y plus delta y is equal to x is common in the numerator, x power n comes out. What do you have inside? 1 plus delta x by x whole power n. You understand this? Now, we want what? dy by dx. dy by dx means the interval needs to be very, very small. Delta x needs to be very small. Delta x is much less than x, means delta x by x is much less than 1. If delta x is much less than x, for a very small interval of x, delta x is much less than x, delta x by x is much less than 1, we know binomial expansion approximation. If x is much less than 1, what do we know? 1 plus x whole power n is equal to, approximately equal to what? We did in the class. Na Mohan చూడకుండా ఒక్కసారి చూడండి దాన్ని. You are not practicing at all. You are just watching the class like a movie and going back home. You don't even know we have discussed it. You have to practice. This weekend you are going to have a test. You will be informed about it by the evening. One plus x whole power n is approximately equal to 1 plus nx. When we were discussing this approximation, binomial approximation, so 1 plus delta x by x whole power n is approximately equal to what? What do we have in place of x? Delta x by x. What do you get? 1 plus n into delta x by x. So put it here. Substitute this here. What do you get? Y plus delta y is equal to x power n into approximately equal to. If delta x is much smaller, that's the case we are discussing. Okay. You'll get 1 plus n delta x by x. Multiply x power n inside. What do you get? X power n plus n x power n delta x by x. Y and x power n get cancelled because y is equal to x power n. What do you get? Delta y is equal to x power n by x is what? X power n by x is x power n minus 1. Take delta x to the left hand side. I should no more call them delta y and delta x. I should call them dy and dx because they are small changes. You understand what I'm saying? Okay, we are talking about small changes. These are small changes. Delta x is much less than x. You can call it as dx. So what do you get? Dy by dx is equal to, what are you getting? N into x power n minus 1. This is the basic formula of differentiation. Okay, when y is equal to x power n, dy by dx is equal to n into x power n minus 1. You need to remember this formula. Note down this, please. If you don't follow up what we discuss in the class with practice, you will forget it. Every day practice whatever is discussed in the class. If you postpone it for 2 days, you will not understand anything. It will look like a foreign language to you. You will not be able to differentiate physics from French if you postpone it for 2 days. So don't delay it, don't postpone it. Everyday practice is required. Only when you practice, you'll get some doubts. You can get them clarified in the next class. So in the tomorrow's class, I'm going to ask you some questions, each individual. I'm going to ask each one of you some questions from what we discussed in the last week until today. All answers to my questions, answers to all my questions will be available in your class notes. So it means tomorrow you will have a test. Consider it a test. If y is a constant, tell me what is dy by dx equal to? You know it. Y is constant. What is dy by dx? Tell me. Rate of change in y with respect to x at a given value of x. Y is a constant. So what is the change in y equal to? When I say y is a constant, what is change equal to? 0. It means y is not changing. If y is not changing, the rate of change in y with respect to x, whether you write delta y by delta x or dy by dx, what do you get? 0. No change in y. You understand this? If y is equal to x, What is dy by dx equal to? When y is equal to x, change in y is also equal to change in x. Small change in y is equal to small change in x. So what is dy by dx equal to? 1. You understand this? Or you can apply this formula. To answer this question, y is equal to x means y is equal to x power 1. So dy by dx is equal to, apply this formula. So what do we have in place of n? 1. So 1 into x power 1 minus 1. What are we getting? 1. You understand this? Next. Y is equal to x square. What is dy by dx equal to? Apply this formula. Dy by dx is equal to 2x. N into x power n minus 1. 2 into x power 2 minus 1. Dy by dx is 2x. Y is equal to 1 by x. What is dy by dx? No. 1 by x means x power how much? Minus 1. Do it. Apply that formula. Minus x power minus 2. Y is equal to 1 by x means x power minus 1. So this is minus 1 into x power n into x power n minus 2. So you'll get minus x power minus 2 or minus 1 by how much? X square. Are you following this? Next, y is equal to square root of x. Find dy by dx. Square root of x means x power how much? 1 by 2. Do it. Correct. చేసి చెప్పురా నాయన, గాల్లో చూసి చెప్తా. So x power half. So dy by dx is half into x power half minus 1. So 1 by 2 into x power minus half. Kada? X power minus half. 1 by 2 into x power half in the numerator, which is 1 by 2 root x. Next, y is equal to 1 by root x. dy by dx. What are you getting? This is x to the power of minus half, right? So minus half into x power minus half minus 1. X power minus 3 by 2. So this is minus half into x power minus 3 by 2 or minus 1 by 2 x power 3 by 2. So like this we can apply that formula. What formula is that? Dy by dx is equal to n into x power n minus 1. Okay. Now similarly we can write derivatives of trigonometric functions also. Y is equal to sin x. Y is equal to sin x. If y changes by dy, it means x changes by dx, right? I'll tell you how we write down this formula, dy by dx, for sin x. For rest of the trigonometric functions, I'm going to write it directly. Okay? You understand what I'm doing? If y1 is equal to sin x1, what is x here? What is x here? Angle. It's a trigonometric ratio. X is an angle, right? So y1 is equal to sin x1, y2 is equal to sin x2. Are you following this? So you know sin a plus b formula, right? Do you know sin a plus b formula? What is it? Sin a cos b plus cos a sin b. You also know that for when theta is very small, you know these approximations. Sin theta is approximately equal to what? Choose cheppu, please. When theta is very small, when theta is close to 0, ఏం చూడటల్లా ఏం ప్రాక్టీస్ చేయట్లా ఉందో లేదో కూడా తెలియదు. For small values of theta, sin theta is approximately equal to theta and cos theta is approximately equal to 1, correct. Cos theta is approximately equal to 1. So dx is very small, right? Dx is a small number. So sin dx is approximately equal to what? Dx. Can I write it like this, please? Cos dx is approximately equal to what? 1. Okay. Substitute these approximations here. What do you get? You will get y plus dy is equal to sin x into cos dx is 1 plus cos x into sin dx is approximately equal to dx. Y is equal to sin x. Y is equal to sin x. So dy is equal to what are we getting? Cos x into dx, or dy by dx is equal to what? Cos x. This is the formula. When y is equal to sin x, dy by dx is equal to cos x. I'll write down other formulae also. When y is equal to sin x, dy by dx is equal to cos x. When y is equal to cos x, dy by dx is equal to minus sin x. Y is equal to tan x, dy by dx is equal to secant square x. You need to remember these formulas. when y is equal to cosecant x, when y is equal to cosecant x, dy by dx is equal to minus cosecant x cot x. When y is equal to secant x, dy by dx is equal to secant x tan x. Y is equal to cot x, dy by dx is equal to minus cosecant square x. These are the formulas you should remember. All right. That's all for today. We will see a few applications of this formula, rules of differentiation, geometrical interpretation of differentiation, etc. in the next class.